We experience time as a relentless flow, always moving forward. Each grain of sand slipping through the narrow neck of the hourglass symbolizes moments that we can never reclaim. This continuous progression is something we all inherently understand and accept as a fundamental aspect of our existence. The past is fixed and immutable. It is a collection of events that have already occurred, etched into the fabric of history. The future, on the other hand, remains unwritten, a blank canvas waiting to be filled with the outcomes of our choices and actions. This dichotomy between the past and the future is a cornerstone of our perception of time. This intuitive understanding of time shapes our perception of cause and effect. Causes precede effects. Actions have consequences. When we make decisions, we do so with the expectation that our actions will lead to specific outcomes. This sequence of events, where one thing leads to another, is how we navigate our world and make sense of our experiences. This is the bedrock of classical physics and our everyday experience. Classical physics, with its laws and principles, operates on the assumption that time moves in a linear fashion. It provides a framework for understanding the natural world, from the motion of planets to the behavior of particles. This framework has been instrumental in the development of technology and our understanding of the universe. But what if this familiar arrow of time could be reversed? Imagine a world where the flow of time is not a one-way street. What if we could turn back the clock and revisit moments from our past? This idea challenges our conventional understanding of time and opens up a realm of possibilities that seem almost fantastical. What if the future could influence the past? This concept, known as retrocausality, suggests that events in the future could have an impact on events in the past. It is a notion that defies our everyday experiences and the linear progression of time that we take for granted. Yet, it is a topic of serious consideration in the realm of theoretical physics. This is the mind-bending concept of retrocausality. It challenges our deeply held assumptions about the nature of time and causality. If retrocausality is possible, it would mean that the future is not just a result of the past, but that the past could also be shaped by the future. This idea has profound implications for our understanding of the universe and our place within it. It challenges our deeply held assumptions about the nature of time and causality. The very idea that the future could influence the past introduces a host of paradoxes and questions. How would our decisions be affected if we knew that future events could alter the past? What would this mean for our understanding of free will and determinism? It suggests a universe far stranger and more interconnected than we ever imagined. In such a universe, the boundaries between past, present, and future would blur, creating a tapestry of events that are all interwoven. This interconnectedness could mean that every action we take has far-reaching implications, not just for the future, but for the past as well. A universe where time itself might not be the absolute ruler we think it is. Instead, time could be just one aspect of a much more complex and dynamic reality. As we continue to explore these concepts, we may find that our understanding of time and causality is just the beginning of a deeper journey into the mysteries of the universe. The possibilities are as vast and infinite as the cosmos itself. Retrocausality proposes a radical idea that an event in the future can cause an effect in the past. This concept challenges the very foundation of our understanding of time and causality, suggesting that the linear progression of time, as we perceive it, might not be the only way to understand the universe. Imagine, for instance, a ball moving on a pool table. In our everyday experience, we see the ball move from one point to another, influenced by the force applied by the cue stick. This is a straightforward example of cause and effect. In a classical world, the ball's trajectory is determined by the force of the cue stick striking it. The direction, speed, and final position of the ball are all outcomes of this initial action. This is how we typically understand motion and causality. But in a world governed by retrocausality, the ball's future position could influence its past trajectory. This means that the final position of the ball could somehow dictate the path it took to get there, creating a feedback loop between the future and the past. This idea may seem absurd at first glance. It defies our intuitive understanding of how the world works. We are accustomed to thinking that the past influences the present and the present shapes the future. Retrocausality turns this notion on its head. It seems to violate our fundamental understanding of cause and effect. The principle that causes precede effects is deeply ingrained in our thinking, from everyday experiences to scientific theories. Retrocausality challenges this principle, suggesting that effects can precede causes. However, retrocausality is not about reversing time or rewriting history. It doesn't imply that we can change past events at will. Instead, it proposes a more nuanced relationship between past, present, and future, where these temporal states are interconnected in ways we are only beginning to understand. It suggests that the relationship between past, present, and future might be far more subtle and interwoven than we realize. This interconnectedness could mean that events are not isolated in time, but are part of a complex web of interactions that transcend our conventional understanding of temporal order. To grasp retrocausality, we must delve into the realm of quantum mechanics, where particles can exist in multiple states simultaneously and can be entangled across vast distances. In this quantum world, the boundaries between past, present, and future blur, allowing for the possibility that future events can influence past ones. Quantum entanglement, for instance, shows that particles can be instantaneously connected, regardless of the distance separating them. This phenomenon hints at a deeper, more intricate structure of reality, where time and space are not as rigid as they appear. Throughout history, scientific breakthroughs have often come from challenging established notions and exploring the unknown. Retrocausality is one such frontier, pushing the boundaries of our understanding and inviting us to reconsider the nature of time itself. As we continue to explore this daring challenge to intuition, we may uncover new insights into the fabric of reality. The implications of retrocausality could revolutionize our approach to science, technology, and even our perception of existence. The journey to understand retrocausality is a collaborative effort, bringing together physicists, philosophers, and thinkers from various fields. Together, they are piecing together a puzzle that could reshape our understanding of the universe. In the grand tapestry of the cosmos, retrocausality offers a glimpse into the profound interconnectedness of all things. It challenges us to look beyond the surface and explore the deeper, more intricate patterns that govern the universe. As we ponder the mysteries of time and causality, retrocausality stands as a testament to the boundless curiosity and imagination that drive human inquiry. It reminds us that the quest for knowledge is an ever-evolving journey, filled with wonder and discovery. To grasp the essence of retrocausality, let's visualize a pond. Throwing a stone into the pond creates ripples that spread outward. These ripples represent the influence of the past, the stone hitting the water, on the future, the expanding ripples. Now imagine if these ripples could somehow converge back to their point of origin, influencing the past event itself. This analogy, while imperfect, helps illustrate how the future might exert a subtle influence on the past. It suggests a universe where time is not a one-way street, but a more dynamic and interconnected system. Quantum mechanics, the theory governing the microscopic world, has long fascinated scientists and laypeople alike. It delves into the behavior of particles at the smallest scales, where the rules of classical physics no longer apply. This realm is filled with strange and counterintuitive phenomena that challenge our understanding of reality. One of the most intriguing aspects of quantum mechanics is the concept of retrocausality, which suggests that future events could potentially influence past ones. This idea, while seemingly paradoxical, finds some support in the phenomenon of entanglement. Entanglement occurs when two particles become linked in such a way that the state of one particle is instantaneously correlated with the state of the other, no matter how far apart they are. This means that a change in one particle's state will immediately affect the other, even if they are separated by vast distances. This instantaneous connection, which Einstein famously referred to as spooky action at a distance, defies our conventional understanding of space and time. It suggests that there is a deeper level of reality where the usual constraints of distance and time do not apply. This interconnectedness raises the tantalizing possibility that information could travel not just across space, but also across time. Could this interconnectedness be a pathway for future events to influence past ones? The idea of retrocausality challenges our linear perception of time, where cause precedes effect. Instead, it proposes a more fluid and interconnected view of time, where the future and the past are not rigidly separated, but are part of a continuous and dynamic whole. Some physicists believe that understanding this interconnectedness might be the key to unlocking the mysteries of retrocausality. They argue that if we can fully grasp the nature of entanglement and the underlying principles of quantum mechanics, we might be able to develop new theories that incorporate retrocausal effects. This could revolutionize our understanding of time and causality, opening up new possibilities for scientific discovery and technological innovation. Throughout history, scientific breakthroughs have often come from challenging established paradigms and exploring new frontiers. The study of quantum mechanics and retrocausality is no different. By pushing the boundaries of our knowledge and questioning our assumptions, we can uncover new insights into the nature of reality. Imagine a world where the future can influence the past, where our actions today could have repercussions not just for tomorrow, but also for yesterday. This mind-bending concept forces us to rethink our understanding of time and causality, and it opens up a realm of possibilities that were previously unimaginable. As we continue to explore the mysteries of quantum mechanics, we are likely to encounter more phenomena that challenge our conventional wisdom. The study of retrocausality is still in its early stages, but it holds the promise of profound discoveries that could reshape our understanding of the universe. The journey to uncover the secrets of retrocausality will require collaboration and innovation. Scientists from various fields will need to work together, combining their expertise to develop new theories and experiments. This interdisciplinary approach will be crucial in advancing our understanding of this complex and fascinating topic. The quest to bridge the past and the future is a testament to the enduring human spirit of curiosity and discovery. As we delve deeper into the mysteries of quantum mechanics and retrocausality, we are reminded of the words of physicist Richard Feynman. I think I can safely say that nobody understands quantum mechanics. Yet it is this very mystery that drives us to explore, to question, and to seek answers. In the end, the study of retrocausality is not just about understanding the universe. It is about expanding the horizons of human knowledge and imagination. It is about daring to dream of a world where the impossible becomes possible, and where the boundaries of time and space are transcended. The journey has just begun, and the possibilities are endless.